Hello students, in this class we will discuss about the elementary calculations of energy consumption. So before entering into topic, we have a general thing. So in our home, in our domestic, in home, generally we have a monthly bill. We will get the monthly electrical bill. Generally it is in 50 units or 100 units like that. For example, for monthly 50 bill is the 50 units, and we will go to the office and we will pay this amount for the 50 units. For example, 1 unit cost is 2 rupees. Then you have to pay the electrical bill is electrical bill is electrical bill is 50 into 2. Then you have to pay 100 rupees. Generally you will pay for monthly. So why we are paying this amount for this? How they are calculating these units? We will discuss in this unit, in this topic. Okay, first here they are calculating unit. Here one unit is nothing but this represents electrical energy. This represents electrical energy. We are paying bill for this, the consumption of electrical energy. You know what is the units of electrical energy? So before entering into the electrical energy, first what is electric power? Electric power is, you know that electrical power is, generally we are paying the money for electrical power, that is consumption of voltage, consumption of current into power factor. We will pay bill for this. Then what is electrical energy? Here electrical energy is the integration of power with respect to time, or we can write directly like this: power into time. Power into time. Generally power units in watts. You know that the power units are in watts. Time, here you have to take generally seconds, but we are converting into the hours. So now the electrical energy can be defined like this. Electrical energy, generally power in watts and time in seconds. So seconds is less units. We are converting in watts into kilowatts. And these seconds into hours. So finally it will convert it into kilowatt hour. The electrical energy is kilowatt hour. Here 1 unit represents 1 kilowatt hour. 1 kilowatt hour. So we are paying the bill for the electrical energy. In the power, here only represents how much of voltage, how much of current. But in power doesn't defines at how much of time the load will running. For example, if you have a bulb, how much of time bulb will running is not represented in electrical power. But how much of power consumed by bulb in particular time is represented in electrical energy. That's why in order to apply the bill, they are giving the electrical energy. They are considering the electrical energy. So we are paying the bill for the electrical energy. That is electrical power consumption by load, and how much of time it is running is represented by the electrical energy. So always we are paying the electrical energy. Here, for example, just look at here. Generally, before entering into this, we have an electrical meter. This is the meter, energy meter. EM is nothing but energy meter. This is we are using generally in our domestic purpose. We are using 230 volts and single phase supply. Our loads required only 230 volts and single phase supply. That's why we have two wires. One wire is phase, another wire is neutral. First, it entering into the electrical energy meter, and after that some main, and after that, after the main we have a switchboard. From the switchboard, for example, we have only two, one is the fan and another one is the bulb. Okay, so for month, how much of time the fan will running, the fan power multiplied with the time, these noted by the this energy meter. And here also, see, bulb is blowing, so bulb will take the power, active power, and how much of it will be running will be noted by this energy meter. So this energy meter, then combination of power of electric fan and the combination of the power of the electric power, both will be combined, the bill will be generated, by this energy meter. So here the energy meter, the bill will be represented in terms of these units. This unit is nothing but 50 kilowatt hours, is nothing but the 50 kilowatt hours. Understand? And whenever it considering this thing, generally if the bulb, for example, we have a bulb. Generally, bulb is a load. It consisting of the, for example, 100 watts load, and it consisting of the, so every load has some power factor. It consisting of the power factor is, for example, 0.8. So if it is bulb, the bulb is running for 6 hours. The time for one day time, it is running 6 hours. For example, 6 hours means night 12 to morning 6 for one day. Then how much of energy consumed by this bulb? So the energy of bulb is, what is the formula for energy? Energy formula is like this. So watts of power, and so generally kilowatts hour, we know kilowatt hour, but here only watt is there. That's why you have to represent 100 by, in order to convert this, we convert the 1000, because it is only watt, here it become the kilowatt. And we have a power factor, don't forget to multiply the power factor, 0.8, and it is the running for 6 hours. Then for example, it running for monthly, it running for the, for example, 100 hours. For monthly, it is running for the 100 hours in order to generate the bill, right? Now the electrical bill generated by the bulb, we can write like this, 2 times and 10. Then the electrical bulb generate 8 kilowatt hours. It will generate 8 kilowatt hours of units. So the electrical energy consumed by bulb is 8 kilowatt hours, or 8 units. We can name it as the 8 units. Energy consumed by bulb. Energy by bulb is 8 kilowatt hours. So then we will pay for these 8 units into some the given value by the our discoms. Discoms will decide the value. Same, for example, you have to do, this is for fan, and you have to go and do with the, this is for bulb. For example, if you are using a fan having 150 watts of rating, and it consisting of the power factor is, for example, 0.7, and it will run for monthly 150 hours per month. Then find out the monthly bill. You will do as a homework. So this process you can apply to your home. So in your home we have more number of bulbs, and more number of fans, and TV, fridge, heater, all those things are there. You can calculate those things, then you will get directly the bill. This is the process to do, find out the calculations required for energy consumption. calculations required for energy consumption. So in order to find out the electrical energy, the need things are electrical power or active power, or active power always involves active power into time, active power into time. Then we will get the this electrical energy. Then we will get the electrical energy. These are the elementary calculations for energy consumption. So energy is generated by sources, generally sources. Electrical power is generated, electrical power generated. Loads are consumes the power, loads are consume the power. Understand? Generating stations are generates the electric power, and loads are nothing but our, everything is load, fan, bulb, etc. all are the loads. I think all of you understand this. These are the elementary calculations for the energy consumption. The most important thing, electrical energy in our home, electrical energy generally represents in units, and 1 unit equal to 1 kilowatt hour. 1 kilowatt hour. Okay? Thank you. Hello students. In this class, we will discuss about the power factor improvement methods. So all of you know the clear idea about the power factor. So we discussed a lot of things, lot of topics related to power factor. Again, I give you the information regarding the power factor in such points. So some of the points. You will go through once again these points, you will understand. Because I didn't explain, the reason is already you have a clear idea about the power factor. That's why directly I am go for the need for power factor improvement. Generally, what is the need to power factor improvement is our topic. First point, generally real power is given by real power or active power, both are same. Real power or active power, both are same. So that is given by VI cos pi. VI cos pi. So the real power or active power, all are same. Active power, all are same. So what is active power? The load consumed power is active power, right? And the electrical current is inversely proportional to the cos phi, generally. So if the active power is generally always active power is inversely proportional to cos pi. If the power factor is low, for example, it takes more amount of current. If the power factor is less, if the power factor is high, it will take low amount of current. So the electrical current is inversely proportional to cos pi. For transferring given amount of power to a certain voltage. Generally the voltage is constant, current is varied. Hence higher the power factor, lower will be current flowing. So for any load, if the power factor is high, then the current flowing it will take less current. A small current flow requires less cross-sectional area of conductors. Generally, in order to increase the current, in order to decrease the current, it will depends on the cross-section area. So current, if in order to increase the current, it will depend on the cross-sectional area of the conductor. What is cross-sectional area? So this area is known as the cross-sectional area of the conductor. Thus it saves the conductor money. So less cross-sectional area conductor we are using, that means we will save the more money. Understand? So in the first point, the current inversely proportional to the power factor. If the power factor value is high, it will take less current. The load will take less current. Less current means less cross-sectional area of the conductor we are using. By that, we will save the conductor as well as money. This is the first advantage of the power factor improvement. Second, from the above relation, we see Having a poor power factor increases the current flowing in conductor. So for example, power factor is less, it will take the more current, and thus copper loss is increased. Whenever the more current is increases, if takes the more current, I square R loss will be increases. A large voltage drop occurs in the alternator. Large voltage drop also occur in alternator. Alternator means a generator. Generator will generate the power, but due to the low power factor, it will take high current. Due to the high current, high drop across the alternator and electrical transformer and transmission distribution lines. So first power will be generated in alternator. From that, the power will be transformed to the transformer. Then it will flow through the transmission line, then to the distribution line, which gives very poor voltage regulation. You know what is voltage regulation? It is the ratio of no load to full load voltage to full load voltage is known as voltage regulation. Always voltage regulation must be very high, it not be poor. Yes. In the second point, so when the power factor is less, the drop across alternator, transformer, transmission, distribution is possible. Due to this, regulation is less. Regulation is poor. Regulation is poor means it will take more voltage drop. Right. Third, the kVA rating of the machine is also reduced by having the higher power factor. If the power factor is high, automatically machine rating will be increases. Machine will generate more power, because the reason is kVA rating equal generally kilowatts by cos phi. Simply don't confuse here. You know these relations actually. That is, what is kilowatts? What is kVA units? kVA units are volt amperes generally. Kilowatts means, what is kilowatts? VI volt. Kilowatt means volt ampere and power factor by power factor. Then both power factor will be cancelled. From that, V volt amperes equal to volt amperes. K will 10 power 3 times increases. That's why we will get the K here. Right? Here, kVA rating of the any machine inversely proportional to the power factor. If the power factor is improves, reduces, kVA rating will be increases. kVA rating will be increases. That will gives the damage. kVA rating increases means what happens? Hence, rating, whenever the rating increases, the size and cost. The size will be increases and cost will be increases. Machines also reduced. Size and cost machine also reduces. Okay. Yes. When the power factor improves, kVA rating will be decreases. Whenever the kVA rating is decreases, the size will be decreases and cost will be decreases. Right. So that's why may increase the power factor, maintain the high rating power factor, then kVA rating will be decreases, the size will be decreases, cost will be decreases. This is why electrical power factor should be maintained close to unity. Always power factor, try to maintain at unity power factor. Try to maintain it unity power factor. It is significantly cheaper. Whenever we are maintaining the unity power factor, the maintenance, the cost is less. The maintenance and cost is less. Okay. So the power factor improvement need is, if the power factor in the first point, if the power factor is low, it will take the more current, the cross sectional area of the conductor will be increases. Yes. The second point, the poor power factor means the voltage regulation is very, very poor. The third point, if you increasing the power factor, the size of the alternator will be decreases. Size of the decreases. So these are the need for improvement of the power factor. And we will improve this power factor by 3 methods. 3 methods, those are capacitor banks is the first method, second method synchronous condenser, third method phase advances. So generally in our loads, to improve the power factor, we will use these 3 methods. Okay, so one by one we will discuss this method. The first method, capacitor banks. Generally, the most important thing when we are connecting a capacitor, capacitor always improves. Capacitor always improves power factor. Power factor will be improved by capacitor. So whenever the inductor coils are here, then it will decreases the power factor. Decreases the power factor. Generally, in the all machines consisting of the coils means, so it look like this inductors. That's why power factor is low. Power factor is low. To improve this, we will connect this capacitor. Improve this, we will connect this capacitor. So improving the power factor means reducing the phase difference between the voltage and current. Power factor improvement is nothing but reducing the phase difference. Understand? Whenever the phase difference is there, the power factor will be increases. So how it is possible? Look at here. Generally, power factor is represented with cos phi. Cos phi. So here, cos phi. Cos phi means what is phi? Phi is angle between the voltage and current. So whenever the angle between the voltage and current phi value is decreases, what happen? Cos phi value increases by the mathematical relation. So here we are doing reducing the phase difference between the voltage and current. Since the majority of the loads are inductive in nature, they require same amount of reactive power for them to function. So we have to compensate the reactive power. Okay, whenever we are operating the load, we have to compensate the reactive power. Otherwise, it is not working. Second, a capacitor bank or bank of capacitors installed parallel to the load provides this reactive power. So generally, low power factor means it requires more reactive power. You have to consider one point. Generally, a load consisting of the low power factor means required more reactive power. It takes more reactive power. Next, high power factor means it requires low reactive power. Low reactive power. Here generally, so that's why a capacitor or bank of capacitors installed parallel to the load provides this reactive power. The reactive power is supplied by this. So generally we have some load. This load is parallelly connected with capacitor. And that if it is inductive load, the required reactive power is supplied by this. Required reactive power is supplied to the load by this capacitor. Okay. They act as a source of local reactive power. So these act as source of reactive power. And there's a less reactive power flows through the line. That's why there is reactive power flows to the line. Capacitor banks reduce the phase difference between the voltage and current. Whenever the phase difference decreases, automatically power factor is increased. Whenever the power factor is increased, automatically the system performance, the load will be increases. So these are the working of the capacitor banks. So in your Google search, just click the capacitor banks and images. You will understand how they look like. Okay. So by the capacitor bank, simply we have more number of inductive loads. Whenever the more number of inductive loads is there, automatically it requires more reactive power. That reactive power is supplied by the capacitor banks. And by using these capacitor banks, we will decrease the phase angle between the voltage and current. Then automatically the power factor will be improved. Next, synchronous condenser. Synchronous condenser means a simple thing, that is, synchronous condenser means You know synchronous motor. So in the machines topic we will discuss the synchronous generator, but we have the synchronous motor also. So here we are using the synchronous motor, the no load synchronous motor. This is the rotor. This is the rotor. No load synchronous motor will supply our required reactive power to the load. Synchronous motor means always this rotor of the synchronous motor rotates with the synchronous speed. A constant speed motor. This is the constant speed motor. Constant speed motor. Okay. Yeah. The synchronous condenser. The synchronous motor, no load synchronous motor, doesn't have any load. The no load synchronous motor, if it connected to grid, then it is called as the synchronous condenser. Condenser means which supplies the compensate the reactive power is condenser. Synchronous means it rotates with the synchronous speed. Okay, no load synchronous motor connected to grid to supply the application is to supply reactive power or improvement of the power. Supply the reactive power, the main thing. So here synchronous condenser are three-phase synchronous motor with no load attached to their shaft. So there is no load actually. The synchronous motor has characteristics operating under any power factor. It can supply the any power factor. Generally power factors are three types. One is lagging power factor. Second one is leading power factor. Third one is unity power factor. Okay. So leading power factor, lagging power factor, unity depending upon the excitation. So in the excitation it will be depend. For inductive loads, a synchronous condenser is connected towards the load side and is overexcited. Generally, synchronous condenser is connected towards the load side. Overexcited synchronous conductor is used. So load side it is and overexcited synchronous motor is used. The load side synchronous overexcited. Overexcited means it is excited more than the field, simply. More than required field. If you are giving the field supply more than a required field, it will act as a synchronous condenser. The synchronous condenser may behave like capacitor. So same as capacitor, this is working as the capacitor. It draws the lagging current, it will get the lagging current from the supply or supplies the reactive power. It will get the lagging power, generally it supplies the reactive power. Understand? So synchronous condenser what is nothing but the no load synchronous motor connected to grid and it is acts as a capacitor. It will supply the leading power factor and lagging power factor and unity power factor. Our required power factor will be supplied. So simply synchronous condenser it acts like a capacitor. The next is the phase advancer. Next is the phase advancer. Phase advancer also useful as the improving the power factor. This is an exciter mainly used to improve the power factor of induction motor. So to improve the power factor of the induction motor is specially designed for the power factor of induction motor. Okay. But synchronous condenser it can be used for any load. They are mounted on the shaft of the motor or connected to the rotor circuit of the motor. So these phase advancers generally, so for example induction motor is like this and it consisting of the rotor. This is the rotor and they are mounted on the shaft of the motor. For example, this is the shaft of the motor. They are connected on the shaft of the motor or connected to the rotor circuit of the motor. So connected to rotor circuit. It improves the power factor by providing the exciting ampere turns to produce the required flux at given slip frequency. So generally it will produce, so the work of the phase advancer is providing a exciting ampere turns. It will produce ampere turns, that means MMF. It will produce ampere turns. What is the MMF? Whenever the MMF is produced in the circuit, automatically it will generate the flux, but it given slip frequency. In the rotor, always generated frequency is slip frequency, not normal frequency. Further, if ampere turns increases, it can made operate the leading power factor. If this ampere turns, that means magnetomotive force will be increases, then it will act as the leading power factor. If ampere turns are increases, leading power factor. If ampere turns are MMF is low, then it acts as a lagging power factor. It will lag power factor. Yes. So these are the phase advances. These are the phase advances. Okay. So these are three methods are useful to control the reactive power, are useful to control the need to improve the power factor. Okay. I think all of you understand this class. Thank you. Hello students. In this session, we will discuss about the battery backup. So already, I think you have idea on the battery backup. Simply, battery backup means, so generally, electrical supply is used for the any load. For example, I will take a example that is our PC, personal computer. Generally, personal computer will take the supply from the electrical supply, general, main or switch. We will take the supply. But suddenly sometimes the supply will be off, but our PC is working. The reason is we have the battery UPS. So we have the uninterruptible power supply. UPS uninterruptible power supply. Interruptible power supply. This is known as the battery backup. It will work for half an hour or 40 minutes in order to complete the work which is disturbed due to the power supply. I think all of you understand this. And this battery backup is very much useful in all the applications. So here, a backup battery provides a power to a system when the primary source of power is unavailable. Whenever this power is not available, this will work. Backup batteries range from small signal cells to retain clock time and date in computers. Generally, this battery backup is always available from small signal cells to retain clock time. So in order to get the clock time, generally use the clock time in order to maintain the time. Small single cells already we used as a backup, and time and date to maintain the time and date in computers. In computers always a small battery backup is there that maintain clock time and date. That's why whenever we on the computer, that time directly it will show the modified date. That point to large battery room facilitates that power UPS supply system. This is also a backup. This is small signal cells is a one type of backup, and this large battery UPS is also one backup. Okay, for maintain the clock and time we have a backup is there, and for large battery also we have a backup is there. So it is the battery backup. Simply whenever the power supply is not available, the work done by the any electrical load by using the battery backup. This battery is used as our backup supply. Backup means whenever is the main is not available, it will be useful. So examples of battery, we have more number of examples. We have very much useful battery backups are explained here. First, aircraft emergency batteries. Generally aircrafts consisting of the emergency batteries. Sometimes aircraft lost their so power supply. Generally aircrafts generate the power supply by consuming the oil, consuming the some liquid type of oils. Sometimes it's not working. The battery will comes into the picture, and that will be useful to land the aircraft. Second, burglar alarm. Burglar alarm means simply generally the restricted areas. So very restricted applicable areas, whenever the human will entering into that, the sensor will work and that will be give the alarm. So in that we will use the backup batteries whenever the supply is not there. Computers, in computers we are directly using the UPS and small cell batteries also. Telephone, we have the batteries. Whenever the supply is not there, it will be useful. Telecommunication networks and data centers. This is very, very important. Generally in telecommunication networks, data centers. So whenever the power supply is there, to maintain the calls and messages for our mobile signals, the signal is maintained. But whenever the power supply is off, that time battery will take that responsibility, that will maintain this telecommunication and data. Next, video game cartridges. In the video games also it is applicable. And the hospitals is very, very much applicable. In the surgeries, whenever the power supply is off, automatically this battery backup will be very much useful. Next, power stations. Power stations also very, very much useful. Battery backups are very much useful. Next, generally I take an example whenever to explain about the battery backup. Here a small difference between the UPS and battery backup. Look at the difference. An uninterruptible power supply, UPS, is also known as the battery backup. It is the battery backup only. Provides backup power when your regular power supply fails. Whenever the power supply is off, it will works. Or voltage drops to an unacceptable level. Whenever the voltage drops also more, automatically less amount of voltage will be into our load. That time also it is useful. A UPS allows for the safe, orderly shutdown of the computer and connected equipment. Understand? UPS generally, whenever the power supply is on, automatically there is no UPS for that, automatically shut down. Then our work will be getting problematic. So half of the problem, if you are not saving that file will be gone. So that's why it is useful for safe, orderly shutdown of the computer. And however, UPS refer to a more advanced version of the battery backup. Generally, it is a battery backup, but advanced version of the battery backup is nothing but the UPS. These are the different battery backups generally in using our daily lives. I think you understand simply because you have an idea in the battery backup. Okay, every system require the battery backup. Okay, thank you.